In this video, we're going to look at some more terms that are very similar to one another, but they are essentially different, and how do we tell them apart. So in the learning of chemistry, we often come across these four terms: atoms, ions, molecules, and particles. So are they the same? Can we use them interchangeably? The answer is no. Okay, so in order to know when to use what, you need to know exactly what each of them stand for. Right, so that is what we're going to look at for the first part of the video. Okay, so for atoms, we're going to look at atoms first. Atoms are defined as the smallest unit of an element that has the characteristics of the element. Right, so what does it mean? It means that if you take an element, for example sodium, alright, and you cut it up into smaller pieces, you divide it repeatedly until you get the smallest unit that still has the properties of sodium. We call that an atom. Okay, very frequently we represent an atom as a circle. Now, in the topic of atomic structure, we went on to learn that an atom is made up of three particles that are even smaller than the atom. Alright, even smaller, so we call them subatomic particles. Sub means smaller than. And these three subatomic particles are your protons, neutrons, and electrons. And we went on to learn that the atom can be represented by a model. Alright, take note that this is only a model. It's not a true representation of an atom. In this model, the protons and the neutrons are closely packed into a very dense region in the middle of the atom, called the nucleus. And how about the electrons? The electrons would orbit around the nucleus, okay, in what we call an electron shell. Alright, so this is how we can represent an atom. And then we went on to learn, how do we know how many protons, neutrons, electrons there are in an atom of any element. Okay, which we went on to learn that an atom of any element can be represented in the following manner. Okay, so from the mass number or the nucleon number and the atomic number, we can actually determine the number of protons, electrons, and neutrons for an atom of any element. Alright, for which I will not go through in detail. If you need to, please re-watch the video on atomic structure. Alright, so just to recap, we have learned that an atom is represented by a circle. From the mass numbers and the atomic numbers, we can determine the number of protons, electrons, and neutrons in an atom. Now, to go further, we need to look at the number of electrons in an atom. We have found out that the number of electrons is actually equal to the number of protons in an atom. Alright, because an atom is neutral, so the negative and positive charges will cancel out. Okay, so essentially from the atomic number, we can determine the number of electrons, which we went on to learn something called the electronic structure. Okay, meaning the arrangement of electrons in electron shell, for which we learned that the first shell, the innermost shell, meaning the shell that's closest to the nucleus, can accommodate a maximum of 2, and subsequent shells can accommodate up to 8 electrons. So with that in mind, with the rule in mind, we can write out how the electrons are arranged in an atom of any element. For example, sodium has 11 electrons. So the 11 electrons are arranged as follows: 2 electrons in the innermost shell, followed by 8 electrons in the next outer shell, and 1 electron in the outermost shell, which is known as the valence shell. Okay, so if you were to write out the electronic structure for an atom of the elements in the periodic table, you will find this, that atoms of most elements are not stable. Okay, how can an atom be stable? In the topic of chemical bonding, we learn that atoms are only stable when they have a fully filled valence shell. So if you look at the electronic configuration of an atom of most elements, they do not have a fully filled valence shell. Okay, so for example, sodium has one electron in the outermost shell, and if we look at another one, chlorine has 7 electrons in the outermost or valence shell. So an atom of most elements, they are actually not stable. Alright, so they do not exist as atoms on their own. Now, how then can an atom become stable? An atom can become stable by losing or gaining electrons. For example, if we look at the case of sodium, sodium can easily lose one electron, and then it forms a particle with an electronic structure of 2.8. And when you lose something that's negatively charged, you will gain a positive charge. Similarly, for chlorine, it can easily gain one electron to form a particle that has a fully filled valence shell. And when you gain an electron, something that's negatively charged, you become negatively charged as well. So when an atom loses electron or gains electrons, it forms a particle that is charged, and the charged particle is known as an ion. Okay, so what is an ion? An ion is a particle, a charged particle that is formed when an atom loses or gains electron in order to have a fully filled valence shell. There are two types of ions. As we have seen, ions can be positively charged when you lose electrons, or negatively charged when the atom gains electrons. So a positively charged ion is called a cation, a negatively charged ion is called an anion. So up to this point, we have defined what is an atom, we have defined what is an ion. We will go on to look at what is a molecule. Now, in the chapter of chemical bonding, we have learned that there are two ways in which atoms can interact with one another. Okay, one way is by the transfer of electrons. Okay, so for example, in the case of sodium and chlorine, sodium wants to lose an electron and chlorine wants to gain an electron. So what is going to happen is that sodium will transfer one electron to chlorine, and they form the respective ions. And since there is a plus and a minus, the ions actually attract each other, and we call this attraction an ionic bond. Okay, so an ionic bond or an ionic compound is usually formed between a metal and a non-metal. Now, the second scenario is when you have two non-metals coming together. When you have two non-metals coming together, if we can recall, non-metals, they only want to gain electrons, they don't want to lose electrons. So if two atoms meet, for example, chlorine and chlorine, both only wants to gain, then how do they interact? Then they must learn to share their electrons. So for example, each chlorine will share one electron. Okay, I'm going to use a different symbol for the two chlorine atoms so that we can see clearly that each atom is actually sharing one with the other. Alright, so sharing, when two non-metal atoms come together, they actually share their electrons to achieve a fully filled valence shell or noble gas electronic configuration. And when they share an electron, okay, they form a covalent bond, and this entity that is formed, okay, this combination of the two atoms, the combined product is called a molecule. So molecules are formed when atoms combine by sharing electrons. And since we have already mentioned that sharing electrons is for covalent molecules, so covalent substances, molecules therefore only apply to covalent compounds. Alright, so it doesn't make sense when we are talking about an ionic compound to use the term molecules. Alright, the reverse is also true. It doesn't make sense when we are talking about covalent compounds to use the term ions. So I repeat again, molecules are formed. Molecules are the particles that are formed when two or more atoms combine by sharing electrons. Alright, so the atoms in a molecule are connected by covalent bonds. Alright, some other examples would be carbon dioxide. So carbon dioxide, in carbon dioxide, the carbon and oxygen atoms are actually combined by sharing electrons. So they are combined by covalent bonds. So what you see here is one carbon dioxide molecule. Okay? So the last term here, particles. What are particles? Particles are a general term. Alright, it's equivalent to humans. Right, human is very generic. There are many kinds of humans. There are males, there are females, there are different races, different religions, and so on. Okay, so particles can be used to refer to atoms, ions, or molecules. Okay, I repeat again. Particles is a generic term that can be used to represent atoms, ions, molecules, or even electrons. Alright, so in a particular context, if you know exactly what the particle is, I'll recommend that you don't use the word particle, but to use exactly what it is. So for example, in a sample of oxygen gas, we know that there are oxygen molecules that are present, okay, rather than oxygen particles. The next few terms that we're going to look at would be attraction. Alright, in our study of chemical bonding, we came across many types of attraction: electrostatic forces of attraction, intermolecular forces of attraction, van der Waals forces of attraction, covalent bond, and ionic bond. So it's easy to get confused between them. So it's very important for us to know exactly when to use what, and or rather what exactly is each type of attraction. Now in science, whenever we see the term electrostatic, it simply means between plus and minus. Okay, so we have learned in science that opposite charges attract. Plus and minus will attract each other. So this kind of attraction is called electrostatic forces of attraction. Okay, before we even go any further, I can tell you that any bond, any kind of bond that we encounter in chemistry is a form of electrostatic forces of attraction. That means any bonds that are formed between atoms, between molecules, between ions is a form of plus and minus attraction. Now, the most obvious scenario where we can see an example of electrostatic forces of attraction is in an ionic bond. Okay, recall that an ionic bond is formed when a metal transfers electrons to a non-metal, and the very famous example would be between chlorine and sodium, or sodium and chlorine. Alright, when sodium transfers an electron to chlorine, it becomes positively charged, and chlorine will become negatively charged. So since they are oppositely charged ions, the charges are going to attract each other. So this is a form of electrostatic forces of attraction between oppositely charged ions. Okay, so therefore we define an ionic bond as the electrostatic forces of attraction. Okay, I'm going to abbreviate this as EFOA, between oppositely charged ions. Okay, now we look at a covalent bond. We have learned that a covalent bond is formed when two non-metal atoms share electrons. So for example, hydrogen will share one electron with another hydrogen. Okay, so when we draw the dot and cross diagram, it's not immediately obvious. Where is the plus and minus? Where is the plus and minus? In fact, some students will go on to ask, sure, electrons are negatively charged, so wouldn't they repel each other? And why would they want to share? Because when we share, the two electrons come together, wouldn't it repel each other? Now that is a very valid thought, but with that we must think about, so since a covalent bond is formed, there must be something that's attracting the pair of electrons. And since electrons are negatively charged, which part of an atom contains something that's positively charged? And when you go along that lines, I hope you can recall that there are protons in the nucleus. Okay, so the protons in a nucleus are going to attract the pair of electrons that are being shared between the two atoms. And a covalent bond is therefore also a form of electrostatic forces of attraction between the protons in the atom and the shared pair of electrons. Okay, so within any molecule you will find a covalent bond. So for example, hydrogen, and a covalent bond is usually represented by a line. So when you look at structures of oxygen and nitrogen, you will find that between each atom there are multiple covalent bonds. Okay, now the remaining two are intermolecular forces and van der Waals forces of attraction. They apply only to covalent substances. Okay, so let's look at the first one, intermolecular forces. Intermolecular. So when we talk about inter-class games, right, inter-class competitions, it is a competition between classes. When we talk about inter-school competition, it's a competition between schools. So when we talk about intermolecular forces of attraction, it's actually the attraction that is between molecules. Alright, so for example, we have seen that a hydrogen molecule looks like this, and in a sample of hydrogen gas there are many hydrogen molecules that exist. So if we zoom into a sample of hydrogen gas, you'll find that there are many hydrogen molecules that are moving rapidly in all directions. Now these molecules can actually attract one another. Okay, they have some form of attraction between one another. Alright, and therefore we call this attraction an intermolecular forces of attraction. Okay, now in higher levels we are going to learn that there are many types of intermolecular forces of attraction, and one of them is called your van der Waals. So van der Waals is not really in the O-level syllabus. Van der Waals represent one type of intermolecular forces, and to know the different types we need to go on further to talk about polarity of bonds, which is not in the O-level syllabus. Alright, so for now just know that van der Waals, if you see the term van der Waals forces of attraction, it simply means that it's a type of intermolecular force of attraction. Now there's another type of attraction that is not mentioned here, but is within our syllabus. So what attraction is that? Is the attraction that is found inside a metal. Alright, so metals, if you can recall, has a giant metallic structure which looks something like this. So the metal atoms actually lose their valence electrons and they form positively charged metal cations. And then we have a sea of delocalized electrons. So the electrons are acting like glue. They are moving around the atoms, the metal cations, to hold the entire structure together. Okay, so a metallic bond. What is a metallic bond? Is actually also a form of electrostatic force of attraction between the metal cations and your sea of delocalized electrons. Okay, so we have looked at many different types of particles and many different types of attraction. So because of the many terms that we use, is a common mistake that students make is to mix up these terms. Alright, you mix and match, and then you end up getting the answer wrong. So it's very important to know in each type of substance what is the attraction present and between what kind of particles, which we'll look at in the next slide. Now in chemistry, we learn three kinds of substances. We learn that there are ionic compounds, okay, and then we learn that there are covalent substances. So substances meaning they can be elements, they can be compounds, and then we learn that there are metals. Okay, so it's very important for each one of them for us to know what is the structure of the compound or the substance, the type of bonding, and between what kind of particles. Right, so what do I mean by that? Ionic compounds, we have learned that they have giant ionic lattice structure. Okay, if you can recall, in the structure, the plus and minus ions are arranged in a regular repeating pattern, where the plus and minus are arranged alternate to one another. Okay, so what holds this structure together is your electrostatic forces of attraction between your oppositely charged ions. Okay, so electrostatic forces of attraction between oppositely charged, the particles would be ions. Why? Because in an ionic compound, it is made out of ions. So the particles that we're looking at are your ions. Okay. For covalent substances, it's a little more complicated. Why? Because in general, covalent substances have what we call simple molecular structure. Okay, so when we are looking at the physical properties of covalent molecules, right, essentially the type of attraction or the type of bonding that we're looking at is your intermolecular forces of attraction that's between the molecules. Okay, so for example, your simple molecular structure, remember hydrogen. So there are many hydrogen molecules and then they are attracting one another with your intermolecular forces of attraction. Now covalent substances can exist in another type of structure. Okay, this is limited to diamond, graphite, and sand. And these three substances have what we call giant molecular structure. So instead of forming many small molecules, what happens is that all the atoms in a substance with a giant molecular structure are bonded to one another. Okay, so an example would be your diamond. So each circle here represents a carbon atom. So what do you notice is that all the carbon atoms are connected to the other carbon atoms. by a line, and a line means your strong covalent bonds. So the type of bonding that we're looking at in a giant molecular, also known as giant covalent structure, are covalent bonds between your atoms. Okay, so remember, in a substance with a giant molecular structure, it doesn't form small molecules, but the whole entire structure is a single molecule. So the attraction that we find between the inside would be between the atoms. The last kind of substance would be your metals. Metals have a giant metallic structure. We have just seen earlier the giant metallic structure, and what we had is again electrostatic forces of attraction between your metal cations and sea of delocalized electrons. Okay. As mentioned, there are many types of attractions, there are many types of particles, and it's very easy to get confused. So one way to be clear is to have a structure in your mind which is divided according to the columns over here. Alright, so in order to know the properties of an ionic compound, you need to just focus on the very first column. Okay, ionic compounds, giant ionic lattice structure, which contains electrostatic forces of attraction between ions. Okay, so if you memorize it column by column, that's when you wouldn't make the mistake of mixing up the different types of attraction, the different types of particles.